All right, so here's the second video, part 2 to it. So question 3 says, McDonald's has a brand name that is recognized 95% around the world. Assuming that we randomly selected 5 people, A says, the probability of exactly 3 of the 5 recognized McDonald's. All right, so very similar to the one above, right? Now it says exactly 3, so therefore X is going to be 3, and N is going to be 5 because we added the 5 people, right? Selecting 5 people. Now here's the question. What is P? So success is recognizing McDonald's. So therefore, recognizing it should be 95%, or in decimal form, 0.95, right? All right, so therefore failure would be 1 minus 0.95, or 0.05. All right, so let's quickly do this. We want the probability of exactly 3 again. So that's 5 choose 3, 0.95 to the third power, and then failure, 0.05 to the 5 minus 3 power. And so this is going to be 10 times 0.95 to the third power, and then 0.05 to the second power. So which gives us a grand total of 0.017. And there we go. Okay. All right, so now let's go on to question B. So question B is a little different. So question B says the probability that 3 or fewer people recognize McDonald's. So let's go back to this little table here, right? So let's make one just for this question here. So again, N is 5, so we go 0, 1, 2, 3, 4, 5. And we found 3 exactly. So for 3, it was 0.017. Now we want 3 or fewer. So the question is, what does that represent as an equality? 3 or fewer. Well, go back over here. 3 or fewer, or less than, right? So I want 3 or less than that. So I want exactly 3 or less than that. So this should look like this as your inequality, right? 3 or less. Remember, going back to 5.1, that meant we're just adding up from 3 and everything less than that. But here's the problem. We don't actually have that. So guess what we have to do? We have to do this until we filled out everything we need. And then, like in 5.1, we add them all up. So I'll give you guys a quick second. Just go ahead and pause the video to try this. Now doing 0, 1, and 2 now. Using the same template we just did. Now do it for x equals 0, x equals 1, and x equals 2. So 3, 2, 1, pause. Okay. So let's try them individually. Okay. So 0, that's just going to be 5 to 0, 0.95 to the 0, 0.05 to the fifth power. For 1, that's 5 choose 1, 0.95 to the 1 power, 0.05 to the fourth power. And then for 2, 5 choose 2, 0.95 squared, 0.05 to the third power. Okay. All right. Okay, so that's going to give us, let's see what we get for each one. It's going to be a super small number. 1, 2, 3, 4, 5, 6. So essentially 0. 5 choose 1 is 5. So hopefully you guys get that for each individual case. So 1 and 0 is super, super small, right? But we wanted 3 or more, right? Or sorry, 3 or less. So we would add up these 3, because that corresponds individually, each one, plus the third one. So adding these up plus 0.071 should give us what? So essentially, right, adding all these up, gives you basically that. So that's 3 or fewer. Okay. Now, believe it or not, there's actually another way to do this as well. Okay. And this word corresponds to something called the complement. So if you guys remember what the complement one is, everything not in what we have, right, or not what we want. So the complement in this case is, well, if I wanted 3 or everything less than that, the complement is everything the opposite. So that would mean more than 3, right, or 4 and 5. So the complement of the probability of x being less than or equal to 3 is probability of x being greater than 3. Because remember, right, going back to section 5.1, what was the rules? All of these must equal 1. So they're actually completely disjoint from each other. So the question is, which one's easier to find? This one, what we want, or this one here? Now remember, the probability of getting greater than 3 means more than 3, so 4 and 5. So the probability or the complement of this is equal to the probability of being 4 plus the probability of being 5. Now in most cases, right, we had to do it actually technically, if we didn't have to do this a part, we actually had to do this 4 times. 1, 2, 3, and 4. Well, here's a question for you guys. What's easier to do? Do this twice or do this 4 times? Well, I'm assuming a lot of you guys say, we'll just do it twice. Now remember, something about complements is if you add up the individual the complements of each other, they must equal 1. So essentially, what we have happening here is, well, we want this is what we're looking for, plus the complement, which is this, equals 1. Or if I just solve for, like a solve for a variable, right, subtract it over, again, this is what I'm looking for. Gives me that. And that's essentially how we're going to use complements for this section. Because sometimes, right, this can go on for like 20 or 30 for x's, and it gets kind of redundant how to do this every single time instead of doing the back way when it comes to it. So another way to write this is, well, I can find what I'm looking for by doing 1 minus the probability of x equaling 4 plus the probability of x equaling 5, and subtract it from 1. So that's the alternative when it comes to it. So this is what I'm going to do for you guys so you can see you get the exact same number in either case. Okay. Right. So first we got to find 2 instead of actually 4 now. We want probably a 4 and then 5. So this is 5 choose 4, 0.95 to the 4th, 0.05 to the 5 minus 4 power, 5 choose 5, 0.95 to the 5th power, and then 0.05 to the 5 minus 5 power. So individually, this is what we get. This is now becomes 0.204, and this one becomes 0.774. So we add these two up, it gives us 0.978. Now if we use the complement rule, we should get the exact same answer from what we have here if we subtract it from 1. So what we're looking for, according to this equation I have written down here, is 1 minus the answer we just got. Did I subtract this wrong? Oh, yes, I did. Huh. No. Let me try that again. 0.0022. Let me see. Did I do this wrong? Why do I get the same thing? It should give me the same thing. What did I do wrong here? This is 1. Oh, there we go. This is off. There we go. Now let's try this again. I thought that was right. Let me see why that's off. This should be exactly the same. Just move on from there. It's interesting. Let me think. I'll send you guys an email. Maybe I'm doing something wrong in my calculations real quick. But they should be the exact same answer. Maybe one of these are off. I got to go back and check them again. But I don't want to hold you guys up when it comes to it. All right. Let's just quickly do number 4, and we'll move on to the next portion there. All right. So a stats exam has 5 answer choices. Only one is correct. Assume you guessed on 3 questions. Find the probability of guessing exactly one correct answer. Then find the probability of guessing all of them. So this is a 2-step process. So the first question is this one. And here's your second question, part B. So there's A and B portion itself. Okay. Now, let's just look at A. Find the probability of guessing exactly one correct answer. All right, exactly one correct answer. Here's the question now. So x is 1, because we want exactly 1. But what is our n in this question? Okay. Now remember, a lot of you guys might say 5, but what are we guessing on? We're guessing on correct answers, right? So the questions. So I want one question correct out of how many? 3 questions. So n is actually 3. Because I want one correct question out of how many total questions? Of 3. Okay. Now, if you wonder where that 5 comes into play, well, what's the probability of getting a multiple choice correct based off this information? Well, one of them are correct out of 1, 2, 3, 4, 5 choices. So the probability of success in this case is 1 out of 5, or 0.2. Therefore, failure is going to be 0.80. Okay, so that's where that comes into play. You got to be very wary when it comes to finding what success is and what the probability is itself, instead of just the end trials. So for part A, we want exactly 1. So x equaling 1. So this is 3 choose 1, 0.2 to the third power, or sorry, to the first power, and then 0.8 to the 3 minus 1 power. All right, so going back this portion, 3 choose 1 should be 3. Yep. 0.20 to the first power is just itself, and then 0.8 to the second power, because that's 3 minus 1, is 0.64. And now we just multiply. Okay, and there we go. So that's A. So this is the probability. Okay, so this is how you interpret your answers. This is the probability of guessing one correct answer out of 3. Okay. Now let's see what's the probability of getting all correct. So the same thing here, right? That applies, but what is x now if I want all of them correct? So I want the first one and the second one and the third one. So this means x is going to equal to 3, all 3 correct. Okay. So this is going to be P3. This is 3, choose 3, 0.2 to the third power, 0.80 to the 3 minus 3 power. So this is going to be 1. This is also going to be 1 because 0.8 to the 0 power is 1. So essentially, it just cares about what the middle part is. So 0.2 raised to the third power is actually a very small number. So your answer is 0.008. So very less than a 1% chance of you getting all correct if you just randomly guess. Isn't that crazy? So this is the probability of you guessing correct all 3 questions correctly. Interesting, huh? So the next one is just a little fun one. Would you take your chances of guessing on a test? Probably not, because you're not going to do very good at all, right, when it comes to it. So there's no way, basically, less than a 1% chance, just by 3 questions. Can you imagine if you have a test on, multiple choice on 20 questions? It's pretty much impossible to actually get them all correct just by pure guessing. Pretty interesting stuff, huh? All right, so that's it for this video. We're going to finish the rest of them. The next video is 5 and 6 on the other side. All right, so I'll see you guys in a little bit.